This is the video on ramps or our introduction to ramps. So this whole unit has been about energy. Now, energy is the capacity to do work. Now, we looked at the law of conservation of energy, and it does state that energy cannot be created or destroyed. We know that only changed or transformed from one form into another or transferred from one object to another. So I wanted to look at that changed or transformed. When energy changes, the mechanical energy will increase or decrease. And when energy transforms, it transforms from kinetic to potential, potential to kinetic, but the mechanical energy remains the same. Now, this happens depending on what force is being applied to it. Now, conservative forces transform energy, energy is stored, and it's path independent. This is going to be the key to what we're talking about in this video. Now, some examples of conservative forces are gravity and the spring force. Now, non-conservative forces change energy. Energy is dissipated as heat and is path dependent. Some examples are friction and mostly all other forces. So let's take a look at work. Now, we've already looked at work. Now, if force is applied to an object or an unbalanced force is applied to that object, the object will change motion or accelerate. If an impulse is applied, then the momentum will change. And if work is done on an object, the energy of that object will change or transform. Now, work is a scalar product of force times the displacement times the cosine of the angle between those two. So you have to have three conditions to be met in order for work to be done. Number one, a force must be applied. Two, the object must move some displacement, and some component of that force is in line with the displacement. So perpendicular components of applied forces to displacement do no work. So here's an easy way to remember it. Positive work is done if the force is applied in the direction of motion. Negative work is done if the force is applied in the opposite direction of motion. And no work is done when the force is applied perpendicular to motion. So let's use that equation for work to answer, well, why do places have stairs instead of a ladder, right? Why do we use stairs instead of a ladder? So let's use this. It's all uphill, right? So this is a simulation where you can change the angle of a ramp and you're pulling a cart up. So let's just take a look before we see what ramps do, like what ramps really do, right? Let's look at somebody like falling, right? So you hit the ground. We've already looked at this. This is impulse, force times the time interval. So what I wanted you to see is that it doesn't matter whether you're falling onto the ground or falling into the water. Either way, you're coming to rest. Same thing if you jump off a table and you bend your knees versus keep your knees locked. Either way, you are coming to rest. You are stopping. But what you are trying to do, right? You are trying to spread that time out as long as possible because that would lower the force. So you hit the water, well, that's going to lower the force. But if you hit the ground, what that's going to do is that increases or decreases the time that force is applied, so increases the force. So we can manipulate those variables, right? So think about dropping your phone, trying to catch it with your hands. You're trying to like stop it with your foot. You're trying to get it on the carpet or a pillow. You don't want it to hit the cement because you're trying to stretch the time interval that force is applied to apply a smaller force to it. So what do ramps do then, right? So let's take a look at a ramp. Let's take a look at the carts going up the ramp. So there's three different carts here. Which cart had the largest amount of work done to it? You can see the amount of work is the same, right? And the reason why is because you're going up against gravity. Gravity is a conservative force. It is path independent, which means it does not matter what route you take to go up to that same height. Your gravitational potential energy is the same. It doesn't matter what angle, whether you go straight up or at a pretty shallow angle. At the end of the day, that cart is going to have the same gravitational potential energy at the top. So that's why the same amount of work is done, right? But look at the one that has the largest amount of force. It's the steepest one. The steepest ramp applies the largest amount of force. Which cart traveled the longest displacement? Well, it's going to be that shallower one, the one on the left, right? So what do ramps do, right? So this is the graph from that simulation, right? So you can see here, as the angle of the ramp increases, you can see the force increases, but the displacement decreases. So let's look at this practically. If you're pulling this cart up the hill, how steep would you want the ramp to be? You'd want it to be really shallow because you want to apply the smallest amount of force to push this cart or pull this cart up, right? Now, the ramp does not affect the amount of energy at the top, but what it's doing is it's allowing that person to apply a much smaller force going up that ramp, right? So think about it this way. Remember when we talked about impulse? Well, a very shallow ramp is a long displacement, right? I'm applying that force for a very long displacement, but it's a smaller force, right? And the steeper you go, well, smaller displacement, larger force until you're going straight up, right? And that's just lifting that object against the weight. So why do mountain roads twist and turn around a mountain? Why not take a more direct route up? So if we looked at the Colorado Mount Evans Scenic Byway, essentially all these switchbacks are just like a compressed ramp. So what they're doing is they're like going up these switchbacks. What that's doing is that's allowing you to sort of trade in that force that you don't want, but apply a smaller force over a larger displacement. That's why you can just casually drive up a large mountain because you're not going straight up. Now, if we looked at the other side of the country at Canton Avenue, it's one of the steepest roads in America. Well, this is just, hey, I need to go up this hill straight directly up. That's a very small displacement going up that hill. So a large amount of force needs to be applied going up there. So this sort of leads into a good segue. How do people use everyday items to use work to their advantage? So we've already sort of talked about ramps. That brings us to this one, right? This is a lab called Created Energy. Spoiler alert, no energy is created. No energy cannot be created. But you can see in this one what it's doing is you're just taking these different objects and sort of categorizing them. How would you categorize them? What do they do? What do they allow us to do? So just as final thoughts, remember there's too much unknown in the universe to take a break from learning. Get out there and question everything.